Chapter 2.2, we're going to be talking about dividing fractions, and one word you're going to hear a lot is reciprocals, and the actual definition of reciprocals is two numbers whose product is 1, and remember that product is going to mean multiplication. They might look like upside down or inverted fractions. Inverted is kind of upside down, and we're going to see some examples of this in example 1. So example 1 is all about writing reciprocals. So if we look at these three original numbers, 3/5, 9/5, and 2, you're going to want to write those down in that order, and then we're going to take a look at what they look like in fraction form. Of course, some of them are already in fraction form, but we'll turn this one into a fraction, and then what their reciprocals look like. Okay, as a fraction, 3/5, of course, is just going to look like 3/5 because it's already in fraction form. Now, if we think about the definition we said for reciprocal, it's basically going to be flipping that fraction upside down. So that means that the numerator 3 is now going to be the denominator on the reciprocal, and the denominator 5 is now going to be the numerator on the reciprocal. And you can see how they just look like they're upside down or flipped. And so this is the reciprocal. And then we can check that by multiplying them and making sure that they come out to be 1. You won't have to do this step every time, but it just kind of shows you how that definition works, that the product of them is going to be 1. Because if we look like we normally do with multiplying fractions, and we look across here and we do some cross simplifying, if you divide both 3's by 3, then those become 1's, and then if you look in the other direction, then you can divide out both 5's by 5, so those will become 1's, so you would end up with 1 times 1 and then 1 times 1, which of course is the same thing as just 1. And like I said, you won't have to do this every single time, but it's just to get in the hang of making sure you're writing reciprocals correctly. For the next fraction, again, it's already in fraction form, and even though this is an improper fraction, we're going to leave it that way because when you go to write the reciprocal, you just want to be able to flip that fraction upside down or invert it. So you want to be able to put that denominator up on the top spot, and you want to be able to put that numerator down in the denominator's place. So 9/5, if it's your original fraction, becomes 5/9 for its reciprocal. And then go ahead and check that. So again, when you check it, you can see the 9/5 times 5/9, and you can cross simplify out by dividing by 9 in this direction, by dividing by 5 in this direction, and again you get those 1's on everything, so you get 1 over 1, which is equal to the whole number 1, and that's exactly what our definition was, the two fractions whose product, so when we multiply them together, give us 1. For part C, remember when they give us a whole number, like in this case they gave us 2, to write it as a fraction we always put a whole number over 1. So as a fraction it's going to look like 2 over 1, and then we can invert it or flip it by having the 2 become the new denominator, by having that 1 become the new numerator. So the reciprocal of 2 is actually 1/2, and just like we did before, you can check it. So in this case, you only had to cross simplify those 2's. If you divide them both by 2, then you get 1's. These were already 1's, so multiplying them across, you get a whole number of 1. For the on your own problems, you're just going to write the reciprocal of the number. You do not have to go through the steps of checking it if you don't want to. If that makes you feel more comfortable, you can. But write the original number down, write it into a fraction if you need to, and then write the reciprocal for your final answer. And you can just box the reciprocal each time, but make sure you remember to write the original problems down first, please. Alright, the key idea as we get ready to move into example 2 is going to be that in order to be able to divide a number by a fraction, you're going to actually multiply that number by the reciprocal of the fraction. And we're going to see lots of examples of this, but you're going to want to have this idea written down because it's going to be the rule that we follow each time we're going to try to divide by a fraction. For example 2, we're going to start by dividing a fraction by another fraction. So we're going to try to find 1/6 divided by 2/3. Alright, start by writing the original problem. That's one thing I've noticed some of you have kind of skipped out on, so make sure you get in the habit of always writing the original problem. When you actually want to divide the fraction, then you're going to go ahead and keep that first number, whether it's a fraction or whole number, the same. It always stays the same. And then you're going to flip that division sign to a multiplication sign, and you're also going to flip that second fraction to its reciprocal. So the original one is 2/3, and if we flip that to its opposite like we did in the example 1, then the 2 is going to go on the bottom and the 3 is going to go on top. So the reciprocal of 2/3 is 3/2. The next thing you're going to do once you've flipped that second fraction to the reciprocal and flipped to a multiplication sign is you're going to look for any cross-simplifying opportunities diagonally. So 1 and 2 can't go any lower because that 1 is as low as it can go. 3 and 6 do have a common factor, and that common factor is 3. So if we divide both of these by 3, then this 3 up here will become a 1, and this 6 divided by 3 will become a 2. And we'll always remember to rewrite those fractions. So 1 over 2 times 1 over 2 is our new set of fractions. So after we rewrite those new fractions as 1 over 2 times 1 over 2, or 1/2 times 1/2, then you just have to multiply like we did in 2.1. So 1 times 1 equals 1, and 2 times 2 equals 4. And since we did do that cross-simplifying earlier on, we can't get any lower than that. So our final answer to the question 1/6 divided by 2/3 is 1/4. In example 3, we're going to be dividing a whole number by a fraction. So we're going to use a piece of wood, for instance, if you needed to cut that. And if it started as a piece that was 3 feet long, and we wanted to cut it into 3/4 foot pieces, we want to try to figure out how many 3/4 foot pieces we can cut from that original piece of wood. And yes, you do need to go ahead and please write that original problem down. One way to solve this problem is going to be to draw a diagram. And again, this won't be what we do every single time, but it's a good idea to just start thinking about this as an option. So if you were to draw out the diagram of just a piece of wood that's 3 feet long, so each one of these is representing 1 foot, then what we're going to do next is we're going to divide each of these pieces into 1/4 foot sections. So you want to try to make them as equal as possible, but mine never end up being perfectly equal, and that's okay if yours don't too. But when you make them into 1/4 foot sections, of course that means each foot has to be broken into 4 equal pieces. So I find the best way to do that is to start by finding out the halfway point and starting there, and then marking each of those halves into other halves, because then you can see you've got 1/4, 2/4, 3/4, 4/4, and you're going to do that for each of your sections of that board. So now each 1 foot board is split into 1/4 sections. Next on your diagram, you're going to count the number of 3/4 foot pieces of wood that you have in this diagram. So if you look at it, you've got 1, 2, 3 right here. That's 3/4, and then 1, 2, 3 right here. And you can see I'm counting the pieces here, 3 right there. And so that's another 3/4, and then you've got 1, 2, 3/4 right there. And I'm just kind of counting and labeling as I go. And I've got the last 3 sections, which are also 3/4. So what that tells us from looking at the diagram is that you have 4 sections or 4 pieces of wood that we can cut into 3/4. So the final answer here to our original problem, which was actually how many 3/4 foot pieces can we cut, it's basically this problem, 3 feet divided by 3/4, and that would equal 4 whole pieces. Now I did say there are 2 different ways that you could solve this problem. So one way was to draw out the diagram. And for some of us that are visual learners, that was probably really helpful to be able to see why we were splitting up the 3 feet boards into the 3/4 pieces. But not everyone is going to want to draw the diagram every time. So method 2 is going to simply be to divide 3 by 3/4, and that's basically going back to the key idea that we talked about, that if you wanted to divide the whole number here by a fraction, that we're going to first turn this first whole number. It's going to technically stay the same, but we can put it over a 1 because we're working with fractions. And then we're going to flip this division sign into a multiplication sign. And when we do that, we're also going to remember to flip that second fraction to its reciprocal. And so the reciprocal of 3/4 is 4/3. And then we just use those regular multiplying steps that we did in 2.1. So we're going to look to see if we can do any cross simplifying. I see 2 3's here across from each other, so we can divide those both by 3 and get them lower. So this one becomes a 1 and this one becomes a 1. Can't really go any lower on these other two because they're already as low as they can go. So our new fractions are going to be 1/1 times 4/1. And when we multiply across, that's 4/1, which is the same thing as 4 because you don't want to leave it as an improper fraction. So we got that same 4 that we got on the last one, and that means, since it's a word problem, you want to make sure you understand what you're answering, that you can cut 4 pieces that are 3/4 foot out of that wood.